All right. So with that, let me introduce Abhinav to the audience today. First of all, a warm welcome to Abhinav Khandelwal. He's an
Thank you.
experienced. Abhinav is based out of Melbourne, so it's a late afternoon for him on a Saturday. So thanks for making time for us, Abhinav. Uh,
That's all right.
Abhinav is an experienced IT professional with more than a decade, 14 years of experience, wow, and has delivered multiple successes in data delivery for large customers. He's currently at Optus as a CD lead and has previously, worked at big organizations, whether it's Teradata or Mahindra Satyam. And he's also the author of the Teradata cookbook. Uh, Awesome. Abhinav, your experience is across finance, banking, retail, entertainment. So wide variety
Yeah.
of sectors. You have focused on, implementing and managing data governance, quality models, analytical architecture, data lakes. Wow. A lot of interesting experience. I'm sure it will come to great use on today's session.
Right.
He's delivered data solutions to large customers in areas of analytics, data migration, end-to-end data frameworks, workload, and performance management for both on-premise and cloud. Uh, and of course, he has a plethora of, the knowledge in whether it's SQL, NoSQL, Postgre, AWS, Tableau, Power BI, so on. Awesome. Abhinav, a very, very warm welcome to our session. I think we are having already we have 73 folks joining. I think we'll get more folks
That's
coming in shortly. So great to have you here and looking forward to this session.
Thank you. Thank you for having me. I'm very excited to do this. This is my first time doing some kind of presentation in front of like so many people. So thanks for having me.
Our
I'm
pleasure.
totally elated. Totally elated.
Great. So Abhinav, what I'll do is I'll pass on the screen share to you so
Sure.
that we can get into the.
So yep, we'll start with the basics, like what are databases, and then we'll move on to the detail, like how we manage the data into databases, why it's important to have a database, and what's the role of a data engineer, especially in this field, and why they should be concerned about the database. Right. So let's start with the database. So you know that. Well, I'll take a simple analogy of what are databases. In your kitchen, every household has a kitchen, right? And in that kitchen you have different things. You need to store all of your vegetables, you need to store your rice, your condiments, your spices, and everything into a regular thing, right? So databases are like that, just for data, right? So in your kitchen you have containers in which you put rice, you put your spices into a smaller box, you put your vegetables in your fridge, right? You organizes them into a better thing. So when somebody says you to fetch a rice for it, you know where the rice is, you know in which cabinet the rice is, right? So this is what database is for data, right? You have tables, you have structures in which you have columns and rows, and in which you populate your data, right? So before, even if you don't know what databases are, or you are not familiar with, not interacting with, directly or indirectly you are interacting with database. You go to an ATM, you take out some money, right? So in on behind scenes you have a database that working 24/7 for you. So when you take out the money, your amount is debited, right? So there is a database that's working behind the scene for you, right? So this is some kind of some databases. So you have different kind of databases. Then you have variety of plethora of databases now. Previously, when the databases started, you mostly heard of Oracle, right? Then as we progress throughout the stages, with the web 2.0 and with the data boom and big data, you kind of hear many names now in databases. Then with cloud, you have now multiple opportunities for databases. Previously, databases were stored in the warehouse in the big companies, data centers, where only way to get access is once you onboard to a company, right? Then only you can get access to those kind of databases. But now with cloud coming in, you can install the database on cloud, you can have free trial, and you can leverage the database. Yeah. So in databases, like I said, you have tables and you have records. in which you store your data. Yep. So that basically forms your database. Yeah. And if I move on to the evolution of databases, you'll see that the database has evolved from 1960s, right? Before, when we don't have databases, what we used to have is paper generals, right? You have seen in the movies where somebody goes to a police station or a government office, and if I asks for an officer for a data, right? So what they do is that they go into a gloomy room, which have files and cabinets, and where they scan through all the files and try to find out the databases. Now that has all be electronically converted, right? As we progress throughout the generations, that has all been electronic converted. Right now you have all these information in the database, so which were in the files, in journals, in ledgers. Now we are talking about tables, rows, columns, right? So they are the same thing, right? So in if I start with the journey of databases, how they evolved. So we used to have a hierarchical model that was developed by IBM, right, in 1960s, where you have a hierarchical model, which is the basic of hierarchical model, which is very basic, that we all know, that you have a parent and then you have childs. For those parents and those childs have childs, right? So it is like an hierarchical, like a family tree. So that was the first of design of the database, in which you traverse from parent to child to scan through a record, right? So this, at that time, because of the computation power and the limitations of storage, this was the best model, right? LD comes in 1980s, when we have .NET boom, when the internet was starting. Then you have network models. Right now, what network model does is that they took the hierarchical models and then they start cross-referencing them. So you have a parent, you have a child, and then that parent can have a different child. Right. So you have a network kind of a model. So that made life pretty simple for getting records, retrieval of the records, and storing of the records. Right. So with the advancement of this 1980s, when you see the era of Oracle, right, in which Larry Ellison and Bob and Ed, they form a company, Oracle, and that's the first name comes to the mind when you heard about the word database, right? To the previous generations, that's the first word they heard is Oracle, right? So that's how the Oracle form, and then you have Microsoft that coming in with the SQL Server, right? So these all are SQL based servers, right? These are all RDBMS. So when I say DBMS, it's database management system, right? The R is relational. So relational means that you have a relation between the entities of the in database, right? So with the boom of internet, right, and with social networking coming in, and with the boom of internet, when the speed of data of internet increase, right, from when we move from 2G to 3G to 4G to 5G, right, that increases the speed. So what it gives it, that it generates more data. Now you can stream data faster, right? Previously we have a limitation that we cannot stream data faster. That's why it was limited. Now you have different varieties. You have mobile phones which are smaller, cheaper, chips are smaller, so they are generating a lot more of data, right? So now it comes that there is a need to store all of this data, right? Previously you have SQL, which has only, we'll discuss more about what's the SQL relational databases in the next slides, but you have starting the urgency of NoSQL, right? So the people who work in web development, they understand that all data is not same, right? You don't have parent child relationship with all the data, right? There is a requirement where you have data type as a video or a movie or a picture, right, a voice, right? Now you want to analyze that documents, you have PDFs, you want to store those PDFs, right? So to store those PDFs, you have NoSQL databases, right, which has different variety of things that has their limitations, right? So based on that, with the need, with the data boom, it comes NoSQL, right? Now we are moving into a new phase, which is called new SQL, right? So new SQL is a mix of SQL and NoSQL, because SQL has some limitations, NoSQL has some limitations. So we are trying to club those two into new SQL, where the ease of data, where you can store same structured and unstructured data into the same database, right? And then you can query those databases pretty efficiently, right? With the cloud coming in, no, you will see more NoSQL, right? You will just need to write a simple SQL, and you don't need to worry about how data is stored at the backend, right? It could be unstructured, structured, you guys don't care, right? You just fire a simple SQL query and data will be fetched. So we are moving into a new generation of new SQL, where you have SQL and NoSQL mixed, right? So there are many limitations with NoSQL, like asset compliance, and it doesn't have SQL support. Standardization is different because Oracle and everything was built onto a standard format. NoSQL is an open source, right? So everyone has their own format. So it's pretty hard for people to understand like which database to use, which queries to use, what is the syntax. So that's changing in NoSQL, right? That's a limitation of NoSQL. Right.
Abhinav, I think there are two questions in the chat box, which I think this slide
Sure.
kind of addresses, but I'll just reiterate.
Sure.
Pankaj's question is, what's the difference between SQL and NoSQL database? I think that you have addressed here.
Yeah.
And Kiran is asking, what SQL topics are important to data engineer in their day-to-day work?
So when you say topic in SQL, I think what do you mean by that is what kind of SQLs are important for data engineers. So what kind of work data engineer using SQLs? So SQL is the basic weapon for a data engineer, right? It's a weapon in your hand to query the data. You can store the data using SQL. You need to retrieve the data using SQL, and then you transform the data into SQL. This is the work of a data engineer, right? So data engineer work is to load the data, transform the data, and then put it into a database where it can be analyzed by data scientists, right? So there comes your SQL. I hope that answers the question.
Cool. Kiran, give us a thumbs up if that makes sense. Ashish is asking, it's more of a career related question. Maybe Ashish, we can take up the career related question at the end of the Q&A. Let's go through the content first. Yeah.
Sure.
All right.
Thank you. Yeah. So I'll move on to the next one, which is DBMS. Now, what is DBMS? DBMS is database management system, right? So DBMS is database, and then we say it's a management system because it's a software, right? So it's a software that is running onto some hardware, right? And that is your database is any other software that is running on your laptop, right? On any of the hardware. So that is DBMS, database management system. Now, database management system are of different kind. As you can see that you have MySQL, you have Apache, you have Postgres, you have Teradata, you have Oracle, you have IBM DB2. These are all softwares that are running on some of hardware. So the software is optimized in a way that you can use the features of those databases, right? That is the function of the DBMS is. So as a student or as a new learner, or you are stepping into a new career of data engineering, the 80% of your work goes into transformation and loading and extraction of the data, right? This is the main work that goes into this for the data engineers. Now the database is accessible. Now how do you query a database, right? There are a plethora of tools. Like if you are using Oracle, then you have Toad, you have SQL developer, you have Oracle developer, different tools. You have Python. Now you have C, you have C++, you have Java that you can query the databases, right? You have different tools. There are some native tools, like for Oracle, you have SQL developer, which is a native tool for Oracle. Like Oracle has built it to purpose to connecting to Oracle, right? It can connect to many different databases, but the purpose is to connect to Oracle. You have Postgres SQL, you have Postgres UI, where you get a UI feature and you can connect to Postgres database, right? Then you have SQL Assistant for Teradata, where the SQL Assistant sits behind this before the scene, and then you query your databases in your using those tools. Yeah. Now we move on to these modeling part of the DBMS, right? So when I say that database management systems are typically designed to organize data according to a specific pattern, right? What does that mean? So I will take that analogy again for the kitchen. So in kitchen, you have a container for rice, right? You don't mix rice and sugar into a same container, right? You can't do it, right? If you do it, then you will cook something else, right? So what the specific patterns means, for a specific type of data, you have specific types of modeling, right? If I am working into a financial institution, my design model would be based on financial institution banking, right? It will have credit, debits, loans, that will have modeling based on that requirement. If I am working in a telecom domain, I will have a totally different set of model. I will have prepaid, postpaid, I will have sim details, I have plan details, I have users detail, I have call details, right? So that would be totally a different kind of a model. Now how does modeling starts? So modeling starts first when you start thinking, right? So that's a conceptual model where you given a problem. I'll give you a problem, I'll give you a say to let's say I want to find out a customer a customer who has watched a recent movie, and now I want to predict what is the next movie that he can see, right? So this is my problem statement. Now for this problem statement, what do you need? You need a customer, you need a table which has all the customer details, you need a table which has all the movie details, right? Now you need a prediction, like you should have a list of different movies that customer has not watched, right? So this, you are trying to build a model, right? Moving from problem to problem. That's your conceptual model. Then you have logical modeling, where you design those tables, right? Where you design the tables on the paper, right? Before you start making into a database, you design that into a table. You say that this is my customer table. This customer table has 5 columns: customer name, customer date of birth, customer gender, and the place of customer, right? So you will have this customer table. Now for the movies, you will have a set of another table. Now to join these two tables, you need to have a relation, right? That's where the word come, RDBMS, relational database. So you need to have relation between these two tables. So in isolation, these two tables can't work, right? You need to have the relation between these two. So that would start generating your logical model, right? Then once you have this logical model in mind, then you physicalize it, right? So it's like building a house. First, you build a blueprint of the house. This is how I want my house, right? You just don't go start digging and start building the walls, and after that you see, oh man, I wanted to build a house, I build something else, right? So that's, you build a blueprint. From that blueprint, you start putting that blueprint into your physical models. That's your data model, right? So data models are made up of, like I say, entities would be your tables, your rows, your columns, so that you can track the data. Now, like I say, there's those entities in isolations cannot work. A customer table or a product table, if they are not joined, they can't work in isolation. What customer has ordered, I don't know, if there is no linkage between those two, right? So then there comes your relationships. You can have one-to-one relationship, you can have one-to-many relationship, you can have many-to-many relationship. So one-to-one relationship, one employee is working in a one department. That's one-to-one. Employee cannot work in 4 different departments, right? That's a one-to-one relationship. Now, one-to-many relationship could be happening is that the student has taken different courses, right? That's one-to-many relationship. Then you have many-to-many relationships, that this course has been taken by many customers, many students, right? So you have many-to-many relationships. So these are kind of a entity-based relationships that you want to conceptualize in your physics when you physicalize your model, right? So this relationship it exists in SQL, right? But it does not exist in non-SQL databases. You don't have relationship in non-SQL databases. They are schema free, right? When I say schema free, is that you take out those rice and that sugar from the container, and then you put that onto a floor, right? You are not putting that into a container now. So the container is your tables which store your data. Now what I'm doing is that I'm taking out those things and putting it to a floor. That's your non-SQL database, right? There is no schema, there is no entity, there is no relationship, right? Because the relationship exists inside that data set itself. The data in NoSQLs are stored in a way that they make sense from themselves, right? So that it could be in a key pair value, or it could be in columnar, or it could be in a different form. So they make sense within themselves, right?
Abhinav, I think we have a
Yep.
question from Shashank.
Uh-huh.
As a data engineer, do we have to create the logical model, or is it given by the client? What is expected from you?
So it depends. Current world where we are modernizing with everything, it's the work of a data engineer, I would say. Previously, we used to have in my generation, right? We used to have a data modeler who used to model the things and give us into an Excel sheet, right? This is your model. Now you go and create. But now with the advancement of everything, the data is flowing in such a rapid speed that you don't know which data is going to come in next. So it's kind of a work of a data engineer now who models it. But then again, it depends on the company or the department or the how you are working. If you are working in an agile fashion, then it's a work of a data engineer. If you are working into a waterfall model, or you are working in a different in a DevOps model, probably you have a data model who will give you the requirements and then you physicalize it. But the physicalization lies with data engineers.
Got it. Purushothaman has two questions.
Yeah.
One is, how is PostgreSQL different from MySQL?
Okay.
And what are the benefits of using Teradata over the remaining DBMS tools?
So Postgres and MySQL are kind of a different. MySQL is a SQL database, and Postgres is a NoSQL database. So they both have a different structure together. But Postgres is now, it has been evolved, right? Previously, Postgres only supports NoSQL, but now Postgres is building their interfaces so that they can support SQL things also. It's getting evolved. Once it has come onto Amazon, it has evolved into kind of a SQL database and NoSQL database. Now the second question was about Teradata has advantages over others, right?
Right. I think he's asking how is it different from other remaining DBMS tools.
So Teradata is not different, I would say, from other DBMS tool. It's just that it gives you a variety. It's a very good question, right? It's not. Let's not compare Teradata with other databases. Compare each databases with each other, right? So the ease for the data engineer, you should be having the ease of connecting retrieval of the database, right? If you have a database in which you try to retrieve a record, right, and that retrieval of a record takes 2 hours, so that database itself is not good, right? So database for data engineer should be built on his requirements, right? But when you go to different companies, the databases and everything are already designed and already set up, right? So what you need to do is that you need to find the right tool that you can use to connect to those databases and work faster. But in terms of databases, different databases has different features, right? Like Teradata gives you now Teradata Vantage gives you an advantage that you can select you can query your non-native data objects, which is sitting in S3 buckets, which is sitting in Excel sheets, and directly query them, right? Just writing a simple SQL and you can query them. You don't need to think about where the data is. With Teradata, you have 4D analytics data types, right? So data types are also important for a database. If let's say you're working on a database and the database does not support timestamp, right, and you are working into a transactional banking system, now how that works if you don't support timestamp? So what you need to do is that you need probably store that timestamp as a string. Now when you query string as a timestamp, it's totally a different scenario, right? That's again give you kind of a different results, or then you need to build your solution around that. Yes, I hope that answers.
Cool. I think one last question on this one from Kedar. I use PostgreSQL to learn SQL. Like I could run SQL queries in it.
Yes.
So now, is it SQL or NoSQL database?
It's kind of a SQL database now. It's the new SQL database now. You can run your SQLs on Postgres.
Got it. Okay.
Okay, thank you. So now, what are the different roles with database? What kind of different roles you have in database, right? So when we say different roles in database, that means that in a database, when you start querying it, you have different roles, right? So how those roles are designed, how those roles are come into effect, right? So once you go in join into company or in your company, right, you could be the admin of those databases. That means you have all the privileges of the world, right? And you have heck lot of responsibility because that database is your responsibility now. Now if you are a data architect, you probably are not worried about querying the database as such, but you need to understand the model of a database, that how your database in your company is designed, right? And you need to adhere to those rules as a data architect. Whatever solution that you are building on to that database, that need to adhere to the rules of those of the database that you have selected, or the model that is building upon. Then you have business intelligence or data analyst or data scientist, or for the databases. Those are the database users who sits in front, right? Those are the users of the database, right? Those are the actual users who do some kind of analysis work on the data that you have ingested, transformed, and stored into a database, right? So your work is to store and transform the data into database. Their work is to consume that data, right? Now if the data that you have stored and transformed is not good, whatever data they are consuming is not good, right? So it's garbage in and garbage out, right? So data BI intelligence and data analyst works is to read that data, to consume that data. Now data engineer, as I said again, is the most critical thing. It's the 80% of the work that a data scientist or data analyst do, is to wrangle the data, right? Even if a data scientist, you provide them all the data into a database, probably they don't like it into the format they have. They need to wrangle the data. They need to join to a different tables. The join is probably is not there. Then they try to bring more data into a database and they join it. So data engineer work is to provide all those things to a data scientist. So data scientist work only remains to execute the models, right? Not to wrangle the data, not to clean the data, right? So data engineer work is, I would say, is the most important thing whenever you're doing any analysis or any analytical work or any data scientist work. If the data is not correct, you cannot predict anything. Yep.
Got it.
Now, types of big data, right? So there comes big data word, right? So what is big data? Big data is not a data which is large. Big data is the amount of data which is huge. You have huge amount of data, right? So you have previously you used to have only structured data. You used to have non-structured data in previous times also. When I'm say previous times in 1900s also, you had unstructured data also. But is that you can't store that data. There is no way for us that we can store that data. Even if you store that data somehow, there is no platform that you can query that data, right? I use that data. Unstructured data is useless for me if it doesn't have any context, right? If a PDF, there is some gibberish line written to me and you give it to me, then I cannot make anything out of it, right? So there comes your structured data, which utilizes that unstructured data and it overlays, it maps to that unstructured data to give some useful information, right? Then you have some semi-structured data, which is mix of structured and unstructured data, which is your kind of your web browsing, where you browses from one page to another. So you have kind of unstructured data, but because it is tagged to you, that browsing pattern, then it could be a structured data. So in structured data, the best and some freely available database is Excel. Excel is, I would say, the free available database for everyone. It has rows, it has columns. You store the data. You can filter the data. You can juggle the data. You can query the data. Excel is the most freely available database to have. Although it's not a database to call upon, but it's kind of a database in its own isolation, right? Now, how this evolved, right? How this structured, unstructured, semi-structured data has evolved over the time is because of the boom of the things that you see on your screen, right? Facebook, Twitter, Instagram, YouTube, right? Likes, comments. So this, every time you do something, it generates a data for these companies, right? For your companies, this data needs to be stored into some kind of, into a database. This cannot be stored into your Excel sheets, right? Even if you can store your photos on an Excel sheet, doesn't make any sense to you, right? So there comes your, sorry, your unstructured data, right? So Google was the driver of this, where they introduced Hadoop to the world, right? MapReduce, where it's used the commodity hardware, right? So there's also one thing that is with this unstructured data is that it is, the storage should be cheap, because we have trillions and zettabytes of data, unstructured data going, that you cannot store them into your expensive data warehouses, right? You need to have a commodity hardware to store those things. And when you have commodity hardwares, the retrieval of data becomes slow, right? Because you know that SSDs are faster than HDDs, right? So because of the limitations of structured and unstructured data, these things come into picture, right? When you query unstructured data, it could take a hell lot of time to retrieve the data than unstructured data, right? So Google introduced us to MapReduce, where you store data into key value where, and then you read those data from Hive or Spark. Now Hive and Spark are turned, to make things easy, they are turning into an SQL based systems, so that user can easily query those unstructured data. All right.
Abhinav,
Yeah.
Adrita has, I think, this is something you covered in the previous slide, but I think she still
Sure,
has
sure.
needs some clarity
Which
on
one?
the, yeah. What is the difference between a data analyst and a data engineer?
Okay. Okay. What is the difference between an analyst and an engineer? So in the word itself, you see analyst and an engineer. Okay. So analyst is the person who analyzes the data, who consumes the data, right? He is the person who is consuming it. In, let's say, in your kitchen, the person who is making the data, who is cooking the food, is the cook, is the engineer, and the person who is eating it is the analyst, right? Because he is consuming that data. So engineer produces the data into a database or into any other thing, and then analyst work is to consume that data, to analyze that data, to predict that data, to forecast that data, to build beautiful graphs from that data. Yeah, I hope that answers.
Yep. And Kedar has a question: which language or software should we
Mhm.
learn for big data?
So it depends on the ease of language, I would say, and the popularity and the availability of all these of the tools. I would say Spark for big data. Spark and is a very good tool that you can learn for big data. You have Hive and Impala, but Spark is widely available. It's open source. Everything is open source in terms of big data. But yeah, Spark. Then you have Python. You have different tools. But I would say Spark and Python would be the best go thing.
Got it. Sanjana's question is around big data. I think, Sanjana, we are getting into the big data and the scope of big data in this section. So just hold on. Kedar is saying if data scientists can also do the work of data analysts, like cleaning, manipulating, visualizing, so in future, will there be a need for data analysts?
So as you are saying, data engineer can do the work of data analyst, is it?
Yeah.
Like I say that if data analysts started doing work of data engineers, their 80% time would be gone into data engineering, right? Because data engineer just not gets the data and put it into a database, right? You just don't cook things. You go to market, you get the vegetables, you drive back home, you wash them, you boil them, you cut them, you mix the spices, then you cook them, and then you serve, right? So this is the whole process. And what does we do? We just eat it up.
Correct.
And let's will just consume it.
I guess
So all those,
Abhinav, Kedar's question is more on the right side of the value chain, right? Whether
okay.
a data
So
analyst
data
versus a data
engineers,
scientist, is there is it getting murky?
No. Data engineers would be in demand and will remain in demand, because those two are different things.
Okay. And how about an analyst versus a scientist?
Analyst and scientist would be a person who has a good degree, right? Who has a PhD holder, or who understand mathematics, who understand statistics, right? Who understands the domain that he is working on, right? But an analyst could be a financial analyst who's working only on financial domain, who's not predicting anything, who's not forecasting much, but who's just analyzing the data that is available to it, right? Who's just reporting onto the data. When I say just reporting onto the data means, like, say I have a requirement where I need to report on to the how many devices I have sold, right? So that's just a reporting. Now, if I have to predict that how many devices I will sold in Q3, there comes your data scientist.
Got it. Well put. And I think Utkarsh really loved your example. He says perfectly explained about the value of data engineers. Thanks, Utkarsh. Fine. And Gaurav wants to understand what's the difference between data wrangling versus data processing.
So data wrangling and processing is kind of a same thing. Wrangling has everything into it. You insert the data, you clean the data, you transform the. It's just that new. It's a new terminology now that we are using, wrangling of data.
Got it. Cool. I think we can move on.
So we have a poll time to now.
Sure. Yes. Exciting time, guys. So you guys will see a poll on the screen. It's a simple poll. Just take a couple of seconds and give your vote. Here we go. All right. What is the ratio between structured and unstructured data available in organizations? What do you guys think? All right. 10 more seconds, guys. Pratyush says Abhinav seems to be a very good cook. Is that true, Abhinav?
No, not that. I cook good pizza, but yeah, not that good.
Got it.
It's just that people in lockdown understand that analogy better.
Makes sense. Yes. All right. Last few seconds, guys. Okay. Let's see the results, Abhinav.
Yep. 2060.
36% have said 40% is structured, 31% say 30% structured, and of course the number goes down. What's your take on this, Abhinav?
I think it's 20 structured and 80 unstructured.
Wow. So there's still a lot of data that's completely unstructured.
Yes.
Got it. Very interesting. All right. Time to move on.
Yeah, let's move on to the next one. So the rise of structured and unstructured data and the big data tools, right? So this graph is, if you see, is exponentially going up, right? It's pretty amazing to see that it's not a trend line, which is
Abhinav.
Yes.
Sorry, Ayushi here. I had a question with respect to the structured data.
Yes.
Go ahead.
Why do we need a semi-structured data? I mean, what is the requirement?
What is the requirement of, structured data?
Semi-structured
data. What is the requirement of semi-structured data? So semi-structured data is, let's say you have a web browsing, right? In web browsing, you have structured and semi-structured data in the sense that when you click onto a page, it generates a JSON data type. It's backend where it says that this this cookie ID has clicked on this one, right? So it kind of unstructured data. But when I use this data when I use to identify that cookie ID to a user, and I join that back to that data set, that row, it becomes a semi-structured data, which has a JSON type and which has a structure type. The or other example that I can give you is that of a complaint, right? Let's say you call to a call center, right? And you complain something about that, right? So that guy, whoever is taking your complaint, he needs to write that down, your complaint into that box. So what it does is that he will type in that request that this customer has given this complaint. Now that thing goes into a database, right? So all of your that complaint that you have said is kind of unstructured, but the second part of it, your customer number, your customer name, your time of contact, your complaint type of complaint is your structured data. So those two things combined gives you a semi unconstructed data, structured data. Make sense?
Yep, she got it.
Thank you. Yeah. So we see that the rise of unstructured data and big data, right? So you can see that how unstructured. So what could you see this boom is because of? What happened? Like the population of Earth has not like exponentially went up, right? What made this gone up? The thing that made this gone up is the speed of internet, the size of chips getting reduced. You can store previously when to my generation we used to have a hard disk not more than 250 GBs, 500 GBs, right? Now you have 8 terabyte of hard disk just in a small 4x4 box, right? That has grown, that has made this graph go up crazy up. So in last 3 years, the amount of data we have generated is equivalent to the 30 years of data that we have generated. That's amazing, right? The kind of data we are generating is amazing. Now also the thing is that we are storing this data. Previously we were letting this data go because there is no way to store this data, because again, if you have seen the pictures, right, this was the size of 1 GB RAM, right? If you have seen the first Apple PC that came out with 1 GB RAM, right? Now because the size chip has gone down, the internet has gone speed up, you have 5Gs now. Because of everything, you can store the data and you cannot let that data go waste, right? So that's why you see that this is an exponentially high, this data. Now this is not just like it went crazy like this, right? Previously also, you guys have heard about CERN, right? A European organization for nuclear research, right? So what they do is that they had an hadron collider where they used to bombard the particles. You must have heard the term God particle. They were trying to figure out, make that God particle. So how do you think that they work? How the people in NASA work at that time when they're not able to store this data, right? They had that unstructured data at that time. You know, when you collide the atom 600 million times per second, they need to analyze all of those 600 million times, right? They need to take those photos and store it somewhere to analyze, right? They were creating that unstructured data in 1960s. It's just that it is now available because of the cloud computing. It is available to us. You can log on to the cloud. You can buy a machine, a big machine, make your programs, and then that's it, right? Previously, this was not available to us. Then you have Internet of Things, right, which is coming into picture now, where you are capturing all of the sensor data. You are capturing you have Tesla now, right? Tesla, the car, that it stores each and every movement of the car. That's how he's able to predict. That's how he's able to self-drive, right? Because the data that she is able to capture, it able to consume and able to produce something out of it, right? The sensor data. Then you have Internet of Homes. Now you have Google Home, you have Alexa. Everything is coming into picture, right? So those things are also making this drive crazy, right? Big data is, as you know, that data is also being used by meteorologists, right? They were predicting the weathers, they were predicting the cyclones, right? That's still going on, but that time it was not available to us. But now it is available to us. So that's why the unstructured data, you can see that it has grown exponentially high, and structured data is growing at its own pace, right? But you cannot say that we don't need structured data, we only need unstructured data. Without structured data, unstructured data won't make any sense, right? If I give you that's why it's like if I give you a dump file of anything, and if you can't make out of any of those data points, and you can't map that to a structured data, there you go. There is no point of unstructured data.
Abhinav, quick time check. We are at 12:20.
Sure.
So how do we want to? I think there's a demo also coming up, right? So if we can quickly spend the next 10 minutes, and guys, there's an interesting demo that we'll show right after this 10 minutes of conversation. So just stick around, and any questions post that maybe we can take. Do we have a little bit leeway on the time, Abhinav?
Sure. So I'll go just with this relational and NoSQL, and then we can go to the demo.
Cool.
Yep. Okay. So I'll just open it with a pun, right? So 3 SQL databases walk into a NoSQL bar, and a while later they walked out. You know why? Because there was no table, right? So if you understood that, there is NoSQL does not have tables, SQLs have tables, right? So they wanted one to a bar and they didn't find a table. So relational database and NoSQL database are trying to marry each other. They are trying to the companies, the Googles and the Facebook, they are now they are understanding it that only NoSQL in his isolation cannot work, because it is hard for people to write queries and try to process the data, right? That's why okay, I think there's a poll that just came up.
Let them walk. You can continue.
Okay.
Yeah,
okay.
Yeah.
Okay. Right. So, yeah. So NoSQL database has its own merits, where you can use all of your unstructured kind of a data, but with the ease of and with the regulation requirement, with ACID requirements, you don't have in your NoSQL databases. NoSQL databases, you probably don't find any schemas and tables, which makes them a little hard for people to digest, of people who does not have SQL backgrounds, to query them and to retrieve the data from it. But if you have a good hand-on SQL, then you can try NoSQL databases with ease. But now with if you read Google's white paper on Spanner, they are saying that we are bringing SQL and NoSQL into one. That's how you are seeing that we are moving into a new SQL world, right? Even Spark and Hive, and they have come up with SQLs, so that you can easily query the tables and you can understand, because SQL is been before NoSQL, kind of 2-3 years there was a gap, but it's easy for people to understand tables and rows other than a document or a key value where. Yep. So which of the databases are you familiar with? People are more familiar with MySQL, which is good to see.
85%.
Yeah, that's a very high rate. I think MySQL is popular, and it's an open source. That's why it's more popular.
Got it. Cool. All right. So I think
let's move on to the demo.
Yeah. So while you set up the demo, right, I will just introduce the program to everybody on the call.
Yes, sure.
So if you just could take us to that slide, Abhinav.
Oh, yep, I'll do that.
Yeah, I can share it while you set it up. That's fine.
Yeah, sure.
So guys, I mean, this has been a really engaging one. I'm not able to cover all the questions. I know we have been going back and forth on the questions. I hope this has been an insightful session, right? At AntWak, what we have done is we are working with experts like Abhinav to come and do a much more involved 16-week program with folks who are looking to transition into data engineering as a career, right? So what we have done is we have folks from just like Abhinav, we have folks from Amazon, Facebook, Kimberly-Clark, IBM, Accenture as well, coming and teaching different modules over the 16 weeks. These are all live classes focusing on both core data engineering skills and professional skills. The program starts in June. You will get hands-on experience on SQL, NoSQL databases, distributed systems, and you will have the opportunity to design and build these scalable and distributed pipelines. The idea is to get your hands dirty. So a lot of emphasis will be given on the projects. And at the end of the bootcamp, there will be 100% placement assistance for people who are looking for a job, including both CV reviews and LinkedIn and mock interviews, and also setting up the interviews for you folks. So do check us out if you guys are interested in making this transition. I will put the link on the chat box as well. If you guys are able to apply today, we have a special offer as well. You will see it in the chat box. Do check us out. We have amazing professionals, including Abhinav. And last week we had Guru Rajan, and then we had Shashank Mishra from Amazon, who are going to be the trainers for you guys. So definitely make use of this if you are really serious about a career in data engineering. Abhinav, if you can highlight, the module that you're working on and what the path to success is for a data engineer, right? Just a minute here before we get into the demo.
Sure. So your path to success, in which I'm gonna pay the path, will be database, model, data, and designing. I'll be covering Postgres and database, MongoDB, in this course, right? So there would be Python, where you will be learning in Jupyter notebooks. Then we will start with some advanced SQLs in Linux. Then we'll have data modeling, which I will tell you that how to model the data before even ingesting into your databases. Then based on that, you will use a cloud. You will be fortunate to use this one. Then you will have gone to the Hadoop, where you will learn unstructured data. Then you will have a chance to create a data lake, right? This term we have not covered in, but data lake is kind of a database in which you dump all the data, right? So that becomes your database, data lake. And then you will use Spark and Databricks, which are very exciting tools. Like somebody asked me in this, what the tools we use. You have here Spark and Databricks. And then you have Kafka, which has been developed by LinkedIn for streaming database, for streaming data there for your IoT and your other purposes. Then you have Kafka. So we have covered all kind of data, structured to unstructured to streaming, and all kind of from premise to cloud to Hadoop to Databricks, which are in demand in the market right now. So you will get to know all of these. You will get a hands-on experience, and you will build your projects based on this thing. Yep. Anything?
Thanks so much for that, Abhinav. Yeah. I was talking on mute. Apologies.
Okay.
Perfect. I think, guys, like I said, this is a very interesting program. Do check it out. Apply on the link. I have posted it in the chat box. One of our counselors will definitely talk to you. Will explain to you in a lot more detail. Program will be starting in June. And it's going to be a roller coaster ride, and we are making it very extremely relevant to you by bringing the right professionals to teach you the right stuff and more practical stuff. So do check it out. Cool. Abhinav, we can move on to the demo. I think that's the interesting part.
Sure. So I'll take that screen. So here, guys, if everyone can see my screen now, right?
Yes.
Yeah. So what we'll do here is that I have Spider 3.8 with Python learning with the same version. And what we will do is that we will import some libraries, which I've already installed. We'll connect to Teradata database. We'll query one table and we'll see the output, right? It's simple, but yeah, let's do this. So I will import pandas and Teradata library. So you see the libraries are imported. Yep. What I'll do here is that I will make a connection. Yep. So that is done. I'll try to make a connection to Teradata. You can see that my username and passwords are hidden. You can't see that. And it will connect to my local Teradata system, which is installed on my laptop. So you have leverage of downloading any database now from your software, because they are software, they will run on your machine. You can download it from their corresponding websites. So you see that Teradata has been connected. I will now, when you query from Python, you need to have a cursor. You will create a cursor that will execute the query in the back, right? So I will execute this select from this table, right? So that's been executed pretty fast. So I have created a session, and that session has fetched the record from this ant test kind of a table, right? Now what I'll do, will execute this. Because it's been executed in Python, it won't have the column names. I'll try to print the column names, give the column names, and I will print the results. Yep, here you go. So you have this data already stored somewhere in the Teradata database. And what I've done is that I've just executed the queries and have demonstrated that how you retrieve the data from this. Now in the course, you will see this is not that easy, right? Because this data has been consumed from somewhere and then have been stored and then have been modeled in a way that you can see in a timestamp format. And this is an integer format. Yeah, so we'll all learn this thing in upcoming classes. Thank you. And I hope everyone is keeping safe and enjoy this
Cool.
conversation.
Thanks, Abhinav. I mean, just a couple of follow-up questions have come up.
For example, sure.
Yeah. So, for example, Gulam is asking that. Oh God, where is it? There you go. Is there any different applications for a data engineer and data analytics in terms of their roles and responsibilities? Gulam, we have tried to address that in the beginning of the session. Do check out the video as well when the recording is there. Like Abhinav was saying, the analytics guy is the guy who eats the food and the engineer is the guy who makes the food. So hope that analogy helps understand. Aishwarya is asking, what is the difference between the BA side for database?
What is the...
I guess she had a previous question. What is the difference between business analyst working on the DB side?
Okay, so business analyst is a person who goes to the business and gather the requirements, right? So he is the face to the business. He goes to the business and he asks, what is your requirement in terms of reporting or developing a solution? If I'm working in a company where I have a product launch and business has a requirement to see the report on those product. So the business analyst will go to business and ask them like, what is the requirement, that what you want to report, how you want to report. And with that requirement, it will come to data engineers or data analysts and tell them, man, this is the requirement. Now you need to develop a solution for that.
Got it. Ashish had asked a question right at the beginning. I am from a mechanical branch, and in the vacancies, educational background from IT branch is required. Will it be easy to get a job in data engineering?
It is easy to get your job in data engineering. You should just need to be passionate about data. You need to have a passion about data. You eat, sleep, and drink data. That's what I can say.
Got it.
Because everything in this around us is kind of a data. If you are passionate about it, then there's no point. There's no stoppage.
Got it. Pankaj had a question asking, data structures and algorithm skills, are they required for a data engineer?
Data structures is yes. Data algorithms is kind of yes and no. It's like depends on the role that you are doing. And kind of a data engineer is also based on your domain. Which domain you are working as a data engineer, right? Yeah.
Got it. I got a couple of new questions. Yeah, Kedar, we have answered that question just about now. Which process of processing data is more relevant in modern data analytics platform, ETL or ELT? Pranshu is asking.
So ETL is extract, transform, and load. ELT is extract, load, and transform. Right. So it depends on the requirements. Now the requirements are in a faster pace. So what we do is that we extract the data and we transform it. Whenever we are extracting, we are transforming the data as we are extracting the data, right? And then we kind of loading it into the warehouse, because once the data is transformed, it is visible to the analyst that it's useful or not, right? Because we are taking a step back. So both are good, ETL or ELT.
Got it.
There are no drawbacks.
Vishwa Prasant has a question. What are some areas to prepare for a data engineer interview?
So what are the
areas to prepare for an interview as a data engineer role?
I think the first thing is the tool and the concept of SQLs, of modeling, and like we said, databases. Those are the important thing for an interview. You need to know the tool that you want to run for a database that you are working on. Then you have modelings, and then you have various concept of data warehousing that you need to learn.
Got it. Abhinav, there was some, first of all, I think a lot of claps coming your way. I think it has been a very good session here. Guys, please do give a shout out on the chat box if you guys like the session. Some people were also asking for your LinkedIn profile so that they can connect with you, only if you're okay with that.
Yeah, sure. That's very pretty. I'm honored to ask that people are asking for my LinkedIn profile. I'll surely share that.
Yeah, so
I think Digvijay has my LinkedIn profile, and you can share that into a chat box.
Yeah, I'm doing that as we speak. So guys, first of all, thanks a lot. I have put out a feedback poll. Just take a few seconds to just give us the rating so that it will help us make the next set of sessions more engaging. Yeah. And in terms of okay, I think I'm having some internet issues, but Digvijay, if you have the LinkedIn profile, can you please post it on the chat box for everybody? Abhinav, once again, million thanks for taking out time on a weekend.
Thank you for having me.
Extremely engaging session. I think a lot of questions. We need to bring you back again soon.
Sure.
And guys, thank you again for coming on a Saturday morning. Hope this was a very insightful session. We will have such sessions coming up every week. So make sure you check out our events page and do sign up for the next set of sessions. Looking forward to the see you guys again. Yeah. And I have shared the chat in the chat box the link for the program that starts in June, 3rd week. Do check it out. Apply for it if you're interested, and one of us will reach out to you and get your details. Cool. Thank you again, and have a good weekend.
Thank you guys. Stay safe. Have a good weekend.